I'd like to welcome everybody back to our afternoon session of the 14th Annual Plant Sciences Graduate Student Council presentation of the Corteva Symposium series here at UW. And my name is John Searle. For those of you who were not here in the first morning session, I am the Vice President this year, and on behalf of the entire council, I'd like to thank you all for attending and making this a great event this year. It is now my pleasure to introduce our next speaker, Stephen Schwartz. Stephen is originally from Noblesville, Indiana, and in 2020 he graduated from Purdue University with degrees in agronomy, crop and soil science, and agribusiness management. He then received his master's from the crop physiology lab at the University of Illinois in 2022. Currently, Stephen works for John Deere as the agronomic value lead for corn and soybean. Through the grapevine, I have heard many great things about Stephen and his work, so it is my very excited ability to listen to Stephen present today. And with that, if everyone can give Stephen a warm welcome.
Good afternoon, everybody. I was thinking back over lunch and over the morning session about something that stood out to me, and something that just popped into my head was diversity and diverse approaches. I remember at dinner last night, we were talking about agroecology. We've heard presentations this morning on botany. We've heard things about genomics, plant physiology. And for me, as somebody who works at John Deere, these have really brought me outside of the systems and structures that I live in every single day. Right? I'm an agronomist. I'm not a genomicist or a plant physiologist by trade, but hearing all the presentations today has really brought me outside of the bubble that sometimes we can live in the industry. But also, I would like to welcome you guys into the bubble that I live in every day. So one of the joys is we get to share this together. So like John said, my name is Stephen Schwartz, and I'm the agronomic value lead for corn and soybeans for North America, for John Deere. And today, we're going to talk about how we see the future of agronomy through the connection of vision systems and equipment. But most people think agronomy and John Deere, those things don't really go together. We're an equipment company, so what the heck are we doing with agronomy? So for me, I participate in something called the LEAD network. LEAD stands for Local, Economic, and Agronomic Decisions. So I work with over 100 John Deere dealers in the United States and Canada to execute over 2,000 field trials in the last 2 years to identify the economic and agronomic value of our technology solutions in the local areas where these farmers operate. Right, we live in Iowa. My Pioneer and Corteva friends are here. A lot of times we publish data from Des Moines, from Johnston, and people who live in other areas, they have a hard time believing that this data is real for them. And so that's why the local part of the LEAD network is really, really important to me, and why we work really closely with our John Deere dealers and customers to deliver value in their local area. But as we think about plant physiology and seeing the future of agriculture, this is the way John Deere thinks about it. We think about sense, decide, and act. So we hear a lot about vision systems and new sensor technology that can help us perceive the world around us, identify what those parameters are that we need to measure, and then we get to this important step of decision. We have to decide, what do we do with this information that we take in, and then how does that inform a highly precise action that our equipment solutions are going to take? Sense, decide, and act. That's our framework, and we want to apply this down to plant-by-plant management. At John Deere, one of our aspirations is that we can manage each plant individually, because we think plants each have their own unique needs that we need to provide for. So we think sense, decide, and act will help us get to true plant-by-plant management. So today we're going to talk about 4 things in a production system that are connecting vision systems and agronomy to this concept of sense, decide, and act. And the first one we're going to talk about is autonomous tillage. So normally when we talk about autonomy and the idea of autonomous tillage, this might be what comes to mind for a lot of consumers. I think every OEM in the world has put out a prototype that looks something like this over the last 10 years. And people think, oh, we're going to have small, cabless, electric power units moving around and doing jobs all across the field. But I would tell you, for a variety of reasons, this is a misconception. And two of the main ones are transportation. It's very difficult to transport these things on roads. The government doesn't really like it very much. Number two, farmers have a deep personal connection to the jobs that they're doing. And whenever we remove a cab off a piece of equipment and show it to a farmer, their reaction is mostly negative. And so at John Deere, we think the future of autonomy looks more like this. This is a tractor, just like any other tractor that John Deere produces today. It has all of the technologies with SFRTK specific guidance, auto track, auto path, auto track turn automation, auto track implement guidance, right? All these technologies that help us farm well, but it also has a suite of cameras. And those cameras allow this tractor to perceive the area around it so that it can identify what's it driving up to? What's it seeing? Does it see a person? Is it going to hit that person? Let me stop. And we've heard a lot about vision systems and CVML this morning and how there's complications in the model. So I'm not saying this is perfect right now, but autonomy is here and autonomy is coming. And it's not just 100% focused on the vision systems. There's a lot of other technologies that go along with it to make this stuff as successful as possible, right? Like auto path, auto track, precise guidance, good boundaries. These things make autonomy possible. That's just to operate the piece of machinery, right? We're here to talk about agronomy. So what does this autonomous tillage have to do with agronomy? Well, it comes back to this concept of job outcomes. Job outcomes could relate to any of the pictures that we see here on the screen. Residue size. How deep are we tilling? How many clods do we have? What's the size of those clods? How level are we? Is the seed bed prepped and ready to plant? And so our vision systems with autonomous tillage also have to be able to tell us how good of a job we did, right? I can take anyone, put them in a tractor and tell them to go till, and they're going to do it. They're going to do a job. Is it the job that we want them to do? Maybe, maybe not. I've seen some bad tillage jobs done on university farms, no offense. And so what we want to do is use vision systems and technology to make sure that the outcomes that we're doing when we don't have an operator are as good or better than what we do have today when I'm driving a tractor. And that requires agronomic understanding and vision systems and other sensor technologies to evaluate what these different parameters are in the field, then identify what the agronomic value of each one of them is, prioritize it, and execute it. That's sense, decide, and act for autonomous tillage. So next, let's go to the planting job step and talk about a product called FurrowVision. FurrowVision is a newer product. It's recently out in the market. It is a set of cameras and laser distance monitoring that goes into the furrow and looks at how deep is your furrow, where's the seed relative to your furrow, and it might tell us some other things in the future about the quality of the furrow. So this is new. This is pretty new. It's a unique opportunity to look inside the trench. So I'll just show you guys what it looks like to plant corn. Most people haven't ever seen this before. When I show this to my plant physiology friends, people get excited. I can see all kinds of things about the environment that our seeds are going into. As for our corn breeders and our soybean breeders, this is a unique look into the environment in which our seeds are placed. What does that trench look like? Is it over-firmed? Is it crumbling too much? Is it crumbling before the seed hits the ground? What's our seed to soil contact? Is that seed actually going to get enough moisture to germinate? Is there residue around the seed? Is that residue going to bring a pathogen in? What can I do to change how much residue is or isn't near the seed? Is my downforce set correctly? Have I over-firmed? Am I going to create hatchet roots because maybe the field wasn't tilled correctly? Now we're planting into it too wet. This gives us the opportunity to truly understand the environment that our seed is placed in. However, the challenge is I just have a camera feed. We talked about this today. You have a lot of data coming in, and we have to identify what are we going to do with all this data. And so the thought process here goes back to CVML, the opportunity to train a system around the images that are coming out of this furrow to identify how much residue do I have? What's the down pressure? And I'll give you an example of what I'm talking about. These are real images from a planter, and these are ways that we would bucket the images to tell us how much residue there is. So we see high, medium, low, or no residue. And there could be a variety of reasons why we have these different residues. It could be corn on corn. It could be corn on corn on corn on corn on corn. There could be different settings with our row cleaners to move residue away from the furrow. But then if I can bucket these, if I can train a camera how to identify residue, how much residue there is, then the question becomes, what's the agronomic value of this? And that's where we, as John Deere, we do a lot of stuff internally, but we also work with partners to help us identify the value, the agronomic and economic value that we could lose or gain by doing this right or wrong. And so there's a lot of opportunities in these images to understand our environment, to make better decisions, and to improve crop outcomes just by using camera systems to identify what's in the furrow. Next, let's talk about spraying. This is See and Spray technology. How many here have heard of See and Spray? Decent amount, good. This is pretty common, popular product. It's been in the news quite a bit. So let me talk you through some of the different types of See and Spray that we have. So there's See and Spray Select. This is a green on brown solution, primarily for our small grains growers in Canada and in the Upper Plains, where we're going to be identifying weeds on a soil or residue background. That's the job of See and Spray Select. Then we have See and Spray Premium and Ultimate. And I like to talk about these together. These are our green on green solutions. So you can take the sprayer into a field of corn, soybeans, or cotton, and it will identify the weeds that are there in the field and spray them with make a targeted broadcast application where the weeds are. And there's some unique differences between See and Spray Premium and Ultimate. Ultimate, as the name implies, is a little bit higher option. With that, you actually have a carbon fiber boom, a dual tank system, so I can broadcast one product and See and Spray another product at the exact same time. It's a new tool in our agronomic toolbox to manage weeds. And whereas See and Spray Premium is just a single tank option. So you can either broadcast or See and Spray with that system. So let me show you a little bit of what See and Spray gives us. This is an example of some of the camera feeds that we're getting from See and Spray and how the system is looking at the rows of soybeans and helping to pick out what the different weeds are in that field. And it can identify weeds down to 1/4 of an inch by 1/4 of an inch. It's pretty small. Now, you can see there on the top, medium sensitivity setting. There's options for our farmers to make decisions about how they want the camera system to work. You can go from lowest to highest and everything in between, which is low, medium, and high. You have 5 settings on sensitivity that helps you decide how aggressive do I want the system to be to see and kill weeds. In a system like cotton, it's much more common for farmers to reduce the sensitivity because they're going to be making multiple passes in the field. So they don't have to hit maybe 100% of every single weed that's in the field today because they're going to come back and forth multiple times. However, a lot of times in the Midwest, we're going to be making 1 post-herbicide application in soybeans, maybe 2 if we're lucky. And so we want to be more aggressive and hit every single weed. But things like See and Spray, this is where we're looking at our weeds, but we're also looking at our crops. Just keep that in the back of your mind. I want to show you a little bit of the data that we're looking at with See and Spray. So on the left-hand side, you'll see this is your normal as-applied map from any common sprayer. When you're using it, you're going to be getting a full coverage map. But then with See and Spray, things look very different in Operations Center. And what's different is that we have these gray areas. And gray is where we covered it with our sprayer, but we didn't spray it. The first time we showed this to some of our farmers, they were really confused. They're just like, I know I covered that area, but it's not showing gray. I moved the sprayer there, and they didn't get it, right? So there's a mental change where now we're just showing you every time we turned the boom on to spray a weed. And while that gives us some resolution as to where the weeds are in the field, We also have weed pressure maps that come out of this system. So not just to tell you where we turned the system on, but actually what are those weeds? Not what are they today, but here's the weeds. What is the weed pressure? In the future, we think there's an opportunity to try to identify what the weeds are in the field. And maybe if our processors become fast enough, we'll be able to identify what the weed is and selectively only spray broadleafs and ignore grass weeds, or vice versa, depending on the agronomic outcome that we're looking for. So there's a lot of opportunities here, especially with weed management, to improve this system. But one of the things I want to highlight is this box here shows 93% of this field did not have any weeds in it. If I have only 7% of my field that has weeds, why would I spray the entire field? That doesn't make sense from an environmental standpoint, and I don't think it makes sense from a weed management standpoint, especially as we're struggling with resistance to a lot of our our old herbicide products. Now, 93%, that's outside the norm, I would say. That's not every single field. Everything's going to vary by conditions, and we're doing a lot of research to understand how things like cropping systems, tillage practices, past management decisions have an impact on your weed presence. Overall, we say See and Spray on average saves 66% of the product that you apply. So in general, you would only be spraying about a third of the total herbicide product when you're using See and Spray. One of the interesting tidbits I like to throw out is we've looked at this data and seen that 72% of your weed pressure for a field is within the first pass around the border of the field. So only about 30% of your weeds are actually in the interior of a field. But as we look at this data and we make passes with See and Spray, we're also learning things agronomically. I like to show this example. This is a field up in Canada with one of my dealers. And that yellow area is where they had planted wheat 18 months ago. And the rest of the field was corn. And then they harvested the wheat, had extra residue where that yellow area is on the map. And then they planted the whole field with soybeans this past year. And if you look at the weed pressure map, we see significantly less weed pressure in the area where we had wheat in the past. And this is the residue effect. We're having a lot of residue from this yellow area that was planted with wheat in the past, and it's suppressing weed emergence dramatically in this field. When we look at the rest of the field that was cropped normally, there's a lot of weeds over there. So we're learning things about how our different cropping systems can have an impact on our weed management systems. Another example I like to use is this one. You can see this field is split in half, and on the left-hand side was conventional tillage, on the right-hand side was strip till. And where we were using a strip till system, we see significantly less spray application and less weeds because, again, we're disturbing the soil less and causing less of those early weeds to emerge in the spring. So these are some of the things that we're learning with See and Spray around weed management. And like I said, right now, we're not identifying weeds in particular. We're just saying, this is a weed, this is not crop, we're going to spray it. But as we talk to our farmer customers and as we ask them what are the opportunities here, one of the first things they ask for is, I need to be able to know what the weeds are. If I have a big flush of weeds somewhere out in the field, it makes a heck of a lot of difference if it's velvet leaf, Palmer amaranth, kochia, burr cucumber, thistle. The decisions that our customers are going to have to make about the herbicide products they choose can all be informed by some of these new data insights that we're getting from See and Spray. So to close out the production system, we're going to talk about harvest automation, right? We're hitting every single job step that our customers are doing. So this is a picture of a John Deere combine. Hopefully, many of you have seen these running around the fields this harvest as our customers have been taking their crops out. And as we think about harvest automation and previous harvest automation systems, in the past, a lot of our systems were reactive. They would take in inputs from the crop, and then they would make decisions about how the combine should be adjusted or make changes. And what we're trying to do with this new combine automation system is, instead of being reactive, let's be proactive. So we put, shockingly, vision systems on the combine that look forward. We have forward perception cameras that can now interpret what crop is coming into the machine, and that's going to help us make better decisions. Now, I like to talk about harvest is a complicated process, and we as humans only have certain things we can do. We have to take in information using all of our senses. We have to see, hear, especially in a combine. Hearing is really important to hear things going wrong with the machine. Feel, I don't think we're tasting anything in the combine, but you can smell smoke or fire if you're going to have a thermal event, as we like to call them. So we have to, as humans, we take in this information, we have to put it into our brains using the matrix decision-making process we have in here. Then we have to decide on an action, and then we have to push a button. With combine automation, we're doing it differently, but it's the same. We're gonna look, we're gonna measure, we're gonna sense, we're gonna put that into an algorithm that has a discrete decision process based on the parameters of the combine and the field. And then we're going to make an action, and we have to automate that action. And now the video I'm going to show you next is what the combine is seeing as you're going through the field. This is going to be a field of wheat, because not only do we have forward-looking cameras, we're pulling in satellite imagery so that we're going to double check what the satellite imagery says in front of our combine, comparing that to our vision system. And when you couple those together, we have a pretty interesting view of what the crop looks like. So this is our machine moving through the field. Now, this isn't shown in the monitor or the display, but as you're moving, but this is a representation of how the machine is making decisions. And as you can see, I'm going to go back. I want to show you this again. We're able to identify areas of more biomass, of less biomass, of downed crop as we're going through this field. You can see all that variation from the combine right here in a field of wheat. There's a lot of data coming into the combine from here. And this is where I like to tie it all back together. If we think back, why is our wheat lying down? Did we apply too much fertilizer? We should go check our as-applied maps. Why do we have more biomass in a certain area? Do we have a bunch of weeds there? Let's go check our See and Spray map. Maybe we sprayed it and we didn't kill it because it's resistant water hemp. We need to make a decision based on that. Why do we have... then on the backside of this combine, we know we have high biomass coming in. It's going to manage that residue. I expect I'm going to have higher residue behind it. How does that impact my autonomous tillage the next year coming through and having to make decisions about high residue? And then how does that residue play into my planter in the spring when I'm trying to look in the furrow to understand what adjustments I need to make to my planter to make sure I'm planting and getting that seed placed in the right way? This is a continuous loop of information, and it's not just one vision system. It's a vision system on our tractor looking at our job quality and tillage, and then into our furrow to understand where our seed is placed, then into the capabilities of the plant, what's going on with the plant, understanding the weeds, and maybe in the future, instead of just looking at weeds, we can look at the crop. And this is where, when I talk to farmers a lot, there's a lot of interest and a lot of excitement to understand, if I have a camera system looking at the crop every time I'm going across it, what can we learn about growth? What can we learn about crop emergence? What can we learn about disease and pests? Right? All the things that we've been hearing from these lightning talks today and these earlier presentations, looking at fusarium in wheat and trying to understand if we can identify them with vision systems, this is what we're doing. This is what we're trying to do every single day to understand how we can make better agronomic decisions, capture that information with our combine, and restart the loop. So I like to end with this slide. This is what it all comes back to. It's sense, decide, and act. And a lot of times we're focused a lot on the sensing. And we have really, really smart people who have to sense and make sensors and make these technologies to identify data parameters within the field. But I think the opportunity, especially for a lot of you as plant science graduate students, is to have an impact in the decision-making process. Because we can have great sensors that look at parameters, but if we don't understand how we need the decisions we need to make based on the data that's coming in, we will not be taking good actions for our farmers. We will not be taking good actions for the land. We will not be taking good actions environmentally. And so that's where, as an agronomist at John Deere, I get to have an impact on the decisions that our vision systems make. And that, for me, is why I get excited hearing all these presentations and seeing things in a diversity of backgrounds, because we get to make decisions as plant scientists that help take this technology to have an impact with our customers and our farmers out in the field. So I'll close there, and I would look forward to taking any questions from you guys. Thank you.
Thank you very much, Stephen. Somebody can move a mic to you if you have questions. Raise your hand. Otherwise, you can submit questions through the QR code found on your tables, and then we will address those as well. While you guys are getting started on questions, I will get us started off here. So you mentioned management for plant-by-plant basis. Mm-hmm. How far out do you think that is? 15 years? 10?
So plant-by-plant management is an aspiration. It's something that we're going after. There's difficulties with that. I'll tell you, there's a lot of work going on internally right now to understand the emergence of every single seed. And so that's really where it starts for us, is in the planting job step when we want to manage plant by plant. If we can understand the environment where every single seed is placed and understand everything about how it came up out of the ground and how it goes throughout the growing season, that for us is plant by plant management. I'm not going to put a hard date on it, but I would tell you we are closer than you think. If you look at, briefly, if you think of a Starfire receiver, GPS receiver on a piece of equipment, right now that's one GPS receiver for a 24, a 16, a 12-row planter. If you were to put multiple GPS receivers on a 4-row plot planter, you could theoretically have a GPS point for every single seed planted on an acre. That would be a great test bed to learn a lot about plant physiology in a smaller area.
I will just say that would be incredible.
It is.
Really cool talk. Thank you. So over lunch, we talked a little bit about short corn.
Yeah.
And, this perceived versus actual adoption by farmers. Are they culturally upset with it? Consensus was no. As long as it yields high enough, people are going to go with it. So I guess, could you talk a little more about maybe the psychology behind this reluctance to adopt different forms of tractors, maybe why that's happening? And do you think you could engineer maybe a good enough new form where farmers would be willing to get rid of the conventional cab and classic look?
I think as we think about changing transportation options for our customers, right? The perception versus reality, there's some boundaries in which we have to operate. A lot of those are governmental. And so there's certain things about being able to hop in there, take over the wheel, and drive it down a road that I don't think are fundamentally able to be changed today, just based on the restrictions we have governmentally. I mean, I'll tell you, if any of you are online or follow a lot of the John Deere influencers on social media, our combines today, once you get going in a full technology suite for a John Deere combine, you hit go, and it follows the path. It will do the turn for you. It will pick up the head for you. It'll drop the head for you. It'll do everything on its own. You have to fill the grain cart on your own. But we're essentially at the point where if you're in a field and you're going, you can hit the button. You don't have to touch anything again. And so we're close to, why don't we just take the cab off? But I would tell you the emotional connection that farmers have to the jobs that they do is more powerful than I think a lot of us realize, and we need to be respectful of that. So I think the cab's here to stay. It's my opinion.
I have a question.
Raise your hand. Where?
Over here in the back.
Yes, thank you.
So if you're thinking about, passing over a field multiple times per year, and then you return to that field year after year, you guys are accumulating mountains and mountains of data. So what is John Deere's overall strategy for managing that, terabytes upon terabytes upon terabytes of data, and what's your future outlook for that?
I'm an agronomist, not a data scientist, and I don't manage all of our data repository. We have a lot of data. I don't know that I can speak intelligently to that question. I'll tell you this: there's things that we take for granted in, say, the operations center, which is our digital platform where we interact with data spatially. There's things that happen automatically that we're calculating all the time, and there's things that I want to compare and analyze that we have to pull in real time to go and grab the data, compare it to another set, do the calculations in real time, and spit out an answer for our customers. We are really focused on making sure that all of this data is as accessible to our customers for them to make good decisions as possible. Unfortunately, I don't have a good answer for you on storage and management of data. I'm sure John Deere has said something about that in the public. I'm just not informed on it. I apologize.
That's okay. Thank you.
What else?
I will jump back in then over here. So you had mentioned the ability to start looking at the crop instead of looking at the weeds with See and Spray. We have a lot of high throughput phenotyping that we do in any breeding program. When can we start thinking of maybe using camera systems from a 120-foot spray boom and really truly making this high throughput at a different scale than what we currently think of in a breeding program?
So as we look at the images that we're going to capture, right, as we take a machine through the field, it's a lot of data to process, like we just talked about. And one of our biggest limitations is weight on the boom. Right now on See and Spray, we have 6 GPUs, VPUs, cameras, camera processing units on the boom. It takes a lot of weight. For us to be able to do this in real time as we're moving through a field, I'm not sure how much more weight we can put on the system in terms of visual processing units, cameras, harnessing to maybe get us where we need to go until the technology moves with us, right? We're seeing a lot of advancements in things like NVIDIA chips and microprocessors. As that technology continues to improve, our ability to do more and more things with the system as we go through the field, it unlocks more potential for us. I'll tell you, our customers are really wanting to understand crop health. That's what they want to understand. I think there's a lot of untapped potential for industry partners and ourselves to understand phenotyping of our hybrids in all of the environments in which our customers operate today. We just haven't fully tapped into it yet.
Yeah, you just mentioned crop health, and I'm thinking from the See and Spray perspective, what's the timeline or trajectory for fungicide or even insecticide maybe application?
Yeah. So one of the things that's really important as we look at sense, decide, and act is we got to prioritize. And so we're always asking the question, what's the highest agronomic and economic value for our customers? And so that changes by geographic region, which is going to inform our strategy and how we make decisions for bringing products up quickly or not. I'll tell you, the economic and agronomic opportunity in a geography like Brazil for using this system to look at fungus and insects is probably higher than our value proposition here in the United States, just because of the higher level of disease presence down in South America. And there's more passes that need to be made across the field. So that's going to change our calculus and how we make decisions about bringing certain technologies to the field. I'll also say we've seen a lot of presentations today about looking at fungus and disease identification. When you're moving 15 mile an hour through a field with a boom, I don't know if we can get today as granular as some of the other technologies that we were seeing to identify down to the head and make a decision there. So there's limits. At John Deere, everything we make, we have standards, engineering standards. And so as it sits right now, I don't think we're going to make a system that is on 4 wheels and small and moves, a mile an hour. Our customers aren't going to take that. And so there's limitations around how precise we can get for fungicide and insecticide while still maintaining our quality of equipment that our customers are used to. Okay. Are we at time? I don't want to go. Okay.
Thank you so much for the presentation. It was awesome. I think as plant scientists, everyone in this room is like super excited about the data that you're generating. And we all have like different ways that we could think about using that data. And so my question is any of this like publicly available? Like, are there data sets that John Deere is planning to open up to the public? Can you pull the data from the combine? Like, could we do our own stuff with this in any kind of way?
Yeah, really important question for agriculture. All of the data that's captured on a customer machine is our customer's data. It's not John Deere's. We don't own it. It's theirs to do with however they please. And so this is a really important distinction, right? Because if you take a See and Spray sprayer across your field, the images from that machine, the weed pressure information, any crop health information in the future, that's not mine, that's Matt's. And so that's where there's some limitations around what we can open up publicly, because all the data it's not John Deere's, it's our customers' data. And to truly get the scale and the access and the ability that folks like yourselves would need to make changes, you'd have to know a ton of John Deere customers and go get them to sign off to release that data to you. So we are not at liberty to just start releasing data, to release our customers' data out into the public. So that's one of the struggles that we have. Now, I know Deere has been working more at universities to do symposiums and, I can't think of the name right now, but we will bring test data to groups at universities and say, hey, model the crap out of this and let's build something out of it. Those are few and far between. Those opportunities don't come very often. So yeah, when it comes to broad-based data accessibility, it all comes down to what our customers want. These are some of the struggles that industry and academia we have to deal with, and we need to find a way forward, because there's opportunity. We just haven't found that way forward yet. Awesome.
I think we got everyone covered. Is that? Yeah, I don't see any hands. All right. I think we're going to be good until the Q&A session for you, Stephen. So thank you very much. So with that, I am now going to be handing over the mic to Mung Mung Luo, and she will be introducing our next speaker.
Hello, everyone. I'm happy to introduce Dr. Matt Clover. Dr. Matt Clover is the Agronomy Innovation Data Leader at Corteva Agriscience. Matt leads a team that works with stakeholders from across Corteva North American seed sales and marketing team to identify critical agronomic and product performance information needs. His team delivers analysis and reporting the reporting to facilitate informed decision-making that drives business growth. Matt first joined Pioneer in 2017 as agronomy research manager with the Pioneer Agronomy Sciences Group. Prior to that, he spent 9 years in the fertilizer industry with various roles in agronomy and research and development. Matt earned his BS in crop sciences and master's in soil fertility from the University of Illinois Urbana-Champaign and a PhD in soil science from Iowa State University, and is currently a certified professional soil scientist. Please join me welcoming Dr. Matt Clover to the stage.